All right, good day, everyone. Today we're going to talk about geometric sequences. If you open your book to page 19, you will see this lesson. First and foremost, we're going to be talking about how to identify a geometric sequence, basically the difference between that and an arithmetic, as well as determining a common ratio within a geometric sequence, okay? Big thing about today is we're going to be discussing a lot of this information and how it pertains to an arithmetic, as well as what are the differences between a geometric and an arithmetic sequence, okay? So let's go ahead and get right into it. For today's lesson, we're going to be talking about, or some background knowledge you need to know, is a 30, 60, 90 triangle for the big one. I have it circled on your screen right there. Basically, the big thing to understand is that in a 30, 60, 90 triangle, the hypotenuse, or the longest side, the side opposite of the 90-degree angle, is going to be always equal to 2x, as well as the 60-degree side is going to be equal to x times the square root of 3. Okay, important information that is needed to go into this lesson. So here's the thing, we're going to start off. Shelley's basically creating a design is for itself, okay? Basically, the design is going to look like this, where we start with the original triangle, and around the polar grid, we're going to get smaller and smaller and smaller, developing more triangles. And she wants to do this at a 30-degree counterclockwise portion. So she wants to create another triangle 30 degrees counterclockwise from the previous one, okay? So basically, if I see this triangle right here, I want to grab a couple pieces of information. So first and foremost, I know that this hypotenuse, this original one right here, is going to be equal to 8. Okay, I know that that hypotenuse is equal to 8. On top of the fact, we know two things. First off, this is my hypotenuse side, so that's got to be equal to 2x, as well as the fact that this side here in blue, not the greatest line, is my 60-degree angle side, so that side is going to be equal to x times the square root of 3. Okay? Now, what Shelley wants to do is create another triangle. And what she wants to do is she wants a 30-degree counterclockwise rotation. What that basically means is if I cut over 30 degrees on a straight line, I am going to create another triangle built into that section. So with the red and blue lines, as you can see, I've almost created a second triangle within that polar grid. But what I want to do is I want to find the hypotenuse of that blue line there, or this second triangle. To do this, I have to go through a little bit of math. Well, notice how in both of these equations, 2x and x plus 3, they both have an x in it. So step one is to figure out what x is equal to. To do this, I'm going to take the 8. So I'm looking for the second hypotenuse. Excuse me. Let me erase this. If I'm looking for the second triangle hypotenuse, I need to take the original length of the hypotenuse, which is 8, and set it equal to 2x. Well, at that point, we should note that x has to be equal to 4. Okay? Well, now if I want to figure out that blue line, or the second hypotenuse actual length, I just have to plug the 4 into my equation. Or in other words, to figure that out, it would be 4 square root of 3, right? So now what I can do is I can change this to have the length of 4 square root of 3. Well, from here, now she wants to build another triangle. So let's say she wants to build a third one. Well, she's going to go 30 degree on a straight line across, cuts down, but now I need to figure out what this hypotenuse is in green. So now I want to find the third hypotenuse. And really, I'm going to follow the same process, but now instead of using the 8, I need to use the 4 square root of 3. So I'm now going to set that equal, 4 square root of 3 equal to 2x, because now that's the new hypotenuse to that leg here, okay? This is now the hypotenuse to this leg. If I work that out, x comes out to be 2 square root of 3. And then I'm going to assume that this here is the 60-degree angle. So it's basically the same exact math, but with a different starting hypotenuse. Now I have to plug this value in for this over here. So I'm going to take 2 square root of 3 and multiply that by square root of 3 to get an answer of 6. So this hypotenuse is 6. Now the thing is that Shelley is going to continuously basically do this down the line. So she's just going to keep making these triangles and gathering smaller and smaller values of this hypotenuse. But if you haven't noticed it, there's a little bit of a pattern each time. Notice how each time I divide by the 2 and then times by the square root of 3. I divide by the 2 to get this, and then I times by the square root of 3. So the pattern itself is each time I get a new hypotenuse, I'm going to times it by this value, okay? So note down here, I basically have it written out for you with that process. If I take 8 and multiply it by square root of 3, I get 4 square root of 3. If I take 4 square root of 3 times it by square root of 3 over 2, I get 6, okay? And I follow this pattern of the new hypotenuse times this value gives me the next one. The new hypotenuse times this value gives me the next one. And I basically just follow this pattern until I get down the line. Now, you can go ahead and finish this chart off if you like in your own notes. You can pause the video and do so, plug them into the calculator and gather these other results. But really all we need is this first 6 terms. On top of that, if you would like to fill out the decimals, feel free to do so. Once again, it's not 100% needed, but if you would like it, go ahead and do that. But to go ahead and move on to the next page, the big thing we want to talk about is if we were to take this information, okay, this chart here, and graph it out, basically you get a picture like this, okay? And the main idea that they want to know is that why isn't this arithmetic, okay? Why is this chart not an arithmetic sequence, okay? And the big thing you want to understand is that to be an arithmetic, you need to have a constant rate of change. In the last sections, we always went up by the same amount each time. We added 2, we subtracted 7, okay? We always had the same increase. The 2 giveaways for this section should be, number 1, instead of adding and subtracting, you are multiplying. That drastically changes your final outcome. And number 2, I don't really have that constant rate of change, okay? Instead, I have something called a ratio, all right? A ratio is basically what we multiply by, or a common ratio is what we use within geometric sequence, okay? This kind of leads us into the next aspect. Geometric sequence is led by a common ratio. It is when we have a pattern of multiplication, okay? The ratio is basically what we are multiplying by each time. Now, this information in front of you is basically describing how to find the actual ratio. When any geometric sequence, if I take a term and divide it by the previous one, it will always come out to be the ratio. So notice how a of 2 divided by a of 1. If I took a of 2, which was 4 over 3, and a of 1, which was 8, and divided them out, 4 divided by 8 would just become 1/2, or the 2 on bottom, and it would give me this value, okay? This works at any point of your sequence. I could take a of 6 and divide it by a of 5 and still get this as an answer. If I take a term and divide it by the previous, it will always come out to be the ratio. So I can write it as this formula. If I take any number and divide it by the previous number in the pattern, it will come out as the ratio, okay? Last thing we really want to talk about is basically how do we come up with the actual equation for geometric sequence. So basically what I have for you here is everything that we're going to be discussing going forward, okay? All the math that we just did, I have written out without the picture, okay? Remember from our starting problem for that triangle, 8 was our starting hypotenuse, and we already talked about how the ratio was square root of 3 over 2. Well, now what we want to do is try to discover how can we use these values to start coming up with certain answers, okay? Or what was our actual math within this problem? So if you note, if I wanted to find the second hypotenuse, I would take the original, which was 8, multiply it by square root of 3 over 2, and it came out as this, okay? That goes back to the chart we talked about way at the beginning where if I wanted to find this value, I would take this times this, okay? But now, how do I actually use these same values to continue this chart on? Well, if you really think about it, to find the third value, I took 8, multiplied it by this 2 times. The first time it gave me this as an answer. The second time it gave me this as an answer, right? So 8 is your starting point, and I took the ratio and multiplied it together 2 times. This pattern stays forward throughout the whole problem. You take the original, times it by the ratio, and it's always how many times did you have to use it. Well, now what we want to do is try to develop an actual formula for this. So if I wanted to find A of n, I have to think what's staying the same and what's changing. Well, notice how each time both the starting point and the ratio never change. So if I'm creating this into an equation, 8's going to stay the same, as well as the square root of 3 over 2, right? The starting point and the ratio never change. The only two things that really have a difference is this. And now we got to try to figure out where's that pattern coming from. Well, if you notice, every value of n, or the number we're looking for, is one less than our exponent. We wanted the fifth term, we used 4 as an exponent. We wanted the fourth term, we used a 3 as an exponent. So what we can do is state we're going to take the term that we're going to use and subtract 1 from it. And every time that will tell us the exponent being used in the problem, okay? This basically helps us derive an equation for this problem. If I want to try to find any geometric sequence, I'm going to take the original term, which is a of 1, and multiply that by the ratio times the term number minus 1, okay? So let's apply this real quick. If I want to find the 11th term, so in letter C, they want us to try to find A11 of this problem. To solve this out, I have to use the first term. So A of 1, the original hypotenuse was 8. I'm going to times that by the ratio, which is square root of 3 over 2. And then from there, it's going to be 11, because that's the term number. Okay, remember the term number states this, subtracted by 1. And from there, I just have to plug that right in the calculator, and I will get my final answer. And that is how we solve and find geometric sequences. Okay. Make sure you finish up and answer the rest of the questions within the video. If you have any questions, please bring them to class tomorrow, and we'll talk about things, and we'll kind of go over anything that you have. All right. Besides that, have a great day, and I'll see you tomorrow.